Welcome everyone. Welcome to this session of What is Consciousness? I'm James Barbieri, the Associate Program Director of the Power Center, and I'll be your host for today. As a host, I'm going to help you throughout the call, so any problem, technical or not, feel free to just drop me a message in the chat. Before we begin, I'd just like to very quickly remind everyone of a couple of Zoom rules for this session. First of all, we ask participants to turn off their microphones during the presentation to ensure a good quality audio. But at the same time, we encourage everyone to turn on their cameras, as we believe seeing everyone's face creates a nice, inclusive education environment. During the presentation, Valerie has offered that if there are any questions that you have that you want answered right away, you're allowed to. So if you want to ask a question, you can either use the raise your hand function, which should be found under reactions at the bottom of your screen. Otherwise, physically raise your hand, and if I see you, I'll call out your name and you can ask your question. Finally, all sessions are recorded, both for archival purposes and for you. So the recording will be available to you all by Wednesday, I believe. So it should come in through your email. If you haven't received it, just let us know and we'll make sure you get it. And yes, that's it about rules. To begin this event, let me introduce our speaker for today, Valerie Hardcastle. Valerie is the Executive Director of the Institute for Health Innovation and Vice President of Health Innovation at the Northern Kentucky University. She's also the Editor-in-Chief of the Journal of Consciousness Studies and the author of several books and essays. She is recently studying how the nature of addiction can shed light on what it means to be human. Today, Valerie will try to answer the question, what is the neural correlate of consciousness? So with that, I'll pass it straight over to you, Valerie. Welcome.
Thank you. Thank you very much. And I'm very happy to be here on my noon. I don't know what time it is for you, but it's a glorious day here. I hope the same for you. What I want to do in my presentation today is not so much dive deep into the neuroscience of the brain, but rather have a more conceptual discussion about what the heck we're looking for when we talk about the neural correlate of consciousness, what some theories are that people have put forward, and then how one might think about starting to evaluate these theories. So if you do not have a PhD in neuroscience, do not worry. This is not the talk for you if you do. Rather, it's more a conceptual examination. Now, I will say I'm going to be sharing my screen to go through my presentation, which means I will not be able to see you. And so if you do have a question, make sure you get James's attention and feel free to ask it, because I would rather address a question, some burning issue that gets raised during the presentation, as opposed to having you just sit on your hands for the remainder of the presentation and maybe forget, or the moments passed or whatever. Okay, so without further ado, I'm going to try to share my screen right here. Let's see. All righty. And now I'm going to get started on the presentation. I'm hoping everybody can see the presentation all right, which means I only see very, very tiny people and only a few of you. All right. So let me just start with a brief outline of what I want to cover, so you'll have a sense of where we're going with this. The introduction is really just a little bit about how to understand consciousness in general. I know you have covered this extensively already, but mainly what I want to do is try to set this up as in a way to help understand the complexity of the issues around the neural correlates of consciousness. So this is not going to be a comprehensive view. Rather, it's going to be sort of my picking and choosing things that I think are relevant to the discussion today. And the bottom line that will come out of the introduction is that things are really complicated. And in fact, if I have to summarize my entire presentation, it would be things are really complicated. So do not expect a neat and tidy resolution at the end. I will then move into some problems that people have with even looking for the neural correlate of consciousness. I probably will not spend too much time here because I think many of these issues have been covered or at least touched upon in the presentations that have come before mine. And then I'm going to finish with a larger section looking at a new way to understand the neural correlates of consciousness, which is trying to understand it from the perspective of being embodied. That is, taking seriously the idea that insofar as we understand the neural correlates of consciousness, they are embedded in bodies that move through the environment. And to truly understand the neural correlates of consciousness, we need to understand the dynamics of the interaction between brain, body, and environment. And then, as I said, we'll come to my conclusion, which, just to give you, again, the preview is it's still complicated. All right. So at first blush, it seems that explaining what the neural correlates of consciousness is should be straightforward. That is, it's whatever happens in our brains when we have a conscious experience that is not happening when we're not having a conscious experience. So we just need to find that little widget in the brain that flips on when we're conscious and flips off when we're not conscious. But this simple answer, I think, is misleading because it turns out there may not be a neural correlate of consciousness, even if we adopt, from the beginning, a very straightforward, hardline, materialistic, reductionist view of explaining consciousness. And to see why this might be the case, I want to explain a bit more definitively what the neural correlates of consciousness, and I'm going to start calling that the NCC, because that gets to be quite a mouthful to say throughout the entire presentation. So I want to explain a bit more definitively about what the NCC might reference. But before I do that, I want to talk a little bit about what consciousness refers to, because dualists and materialists disagree with each other on just about everything, as I'm sure you've probably learned. But they do agree, it seems, at first blush, about the phenomena that they're trying to explain. Okay, so John Searle, for example, says consciousness refers to those states of sentience and awareness that typically begin when we wake up from a dreamless sleep and continue until we go asleep again or fall into a coma or die or otherwise become unconscious. So being sentient or being aware seems to be a pretty straightforward account of consciousness. Even if you don't know what being sentient actually is or what being aware actually is, it does seem like we have, a conceptual framework around which to hook our investigation. But a closer look shows that this does not fully account for the complexity of conscious phenomena, because intuitively, we would want to say that both of the following are instances of being conscious. On the one hand, being aware of the brown table in front of me as being brown and being a table. And on the other hand, we want to say it's being alert and ready to interact with the environment. So people use consciousness to refer to both of these things. And these two cases are different enough from one another that it might make sense to understand consciousness as a set of phenomena and not as a unitary thing, at least until we know more about what consciousness is exactly. We should probably divide consciousness into at least two categories. One is being aware of a perception, and the other is being in a state such that we can have a perception in the first place. So one is the case that this is, these are the qualia. These are the things I feel, I see, I smell, I touch, I taste. On the other hand, it's also sometimes referencing, being awake and alert as opposed to unconscious, comatose, vegetative state, and so forth. So both of these domains are described as being conscious. So following David Chalmers, we can talk about content states of consciousness and background states of consciousness. And the content states are what most philosophers mean when they talk about consciousness. These states are the fine-grained states of subjective experience that one has at any given time. They encompass, for example, the experience of a sound pattern of a song one's listening to, the experience of a soft surface one is touching, or the experience of your own internal train of thoughts. These conscious states are specific events in our day-to-day experience, and David Chalmers references them as content states because they're usually differentiated by their content. That is, the specific sound of the pattern, the specific haptic feeling, the specific thought, and so forth. And that's how we talk about them. You know, the smell of the rose, that's my conscious experience. The content of states of consciousness are also sometimes called phenomenal states or subjective experiences or qualia. These all are names for the way things seem to us. And while we may not know what consciousness is exactly, we do know a lot about where and how perception is processed in our brains. Some of these experiences are conscious, so perhaps this is the way in to identifying what it is that happens in our brains when we're conscious, right? So if we know how visual perception works, or at least parts of visual perception. We know that we are conscious of some visual experiences. So if we could just figure out where in the visual stream things become conscious, then we might have identified the neural correlates of consciousness. Now, on the other hand, we have the background states of consciousness, which are the overall states of being awake, being asleep, being dreaming, being under hypnosis, and so on. This is what doctors are referring to when they say their patient is conscious. These states are the common framework for the more specific conscious states, like the content states of consciousness, and they can influence the latter. For example, different background states of consciousness, such as being alert as a healthy individual, or being alert, but you have schizophrenia, may affect the way you perceive objects and events in the world. We would expect, indeed, we actually know that the brains of patients with schizophrenia are structurally different than the brains of normal controls. And these two types of brains react differently sometimes when they're given the same stimuli. We know that some things that are going on in the brain that keeps us alert and oriented. We know some of that, though we don't know about that as much as perception. And perhaps this too is a way into identifying what it is about the brain that connects alertness with being aware. So if we could figure out that trigger in the brain that moves us from being in a coma to being awake, then maybe that would give us insight into what consciousness is in the brain. It's clear that these two main categories of conscious states are related to each other in important ways, but they're also connected to different brain structures. The parts of our brain that perceives things in our environment is very different from the parts of our brain that keeps us oriented to the world. And yet, something must distinguish those neurons, those neural firing patterns, or the brain structures that are aligned with consciousness from those that are not, because it's not the case that everything that happens in your brain you're conscious of. And if we could isolate what that something is, then perhaps we found the neural correlates of consciousness. Okay, so Francis Crick and Christoph Koch were really the first ones to discuss the ideas of NCCs in the scientific press in a very serious fashion. And their first paper came out in 1990. So this is how long this conversation has been going on. They started by assuming, and most people do when they talk about this, an unabashedly materialistic position that consciousness is part of the physical world. Insofar as we can understand the physical world, then we'll be able to understand consciousness. It seems like a very good bet to say it's connected with our brain. So we're going to start the examination there. They argued that eventually consciousness does have to be explained by something at the neural level. Then they assume that, and this is quoting the 1990 paper, all different aspects of consciousness employ a basic common mechanism, or perhaps a few such mechanisms. So they think consciousness is a thing in the brain. Now, thing may not be, an object. It might be a neural firing pattern, or it might be a process, but it's a thing in the brain that we can identify, and it's a fundamental thing. So it's not like we've got 85 different things that give rise to consciousness in the brain. And that is, they just assume that whatever consciousness is, it can be explained by a single thing in the brain, the thing that distinguishes conscious brain activity from unconscious brain activity. And this is a really important and significant presumption, for they're claiming more than consciousness just being correlated with some brain activity. They're claiming that understanding the difference between conscious and unconscious phenomena will depend fundamentally on understanding something about the brain. Okay, so to understand consciousness at all, they believe you have to understand the brain. In their original paper, they argued that consciousness is realized by a group of cortical neurons all firing together in unison at some particular frequency. They first were suggesting 40 Hertz oscillations. This is one possibility for what the mechanism of consciousness might be. And it was very popular back in the late 80s and early 90s when I was in graduate school. Everybody was looking for these areas of brain that would be firing in unison, and you'd get these nice 40 Hertz oscillations. It seemed to be correlated with perception of complex objects. And then it was just a very tiny leap for people to decide, well, that is probably where we're going to find consciousness. But there have been many other proposals floated over the years. For example, about the same time as Crick and Koch were postulating the neural oscillations as the correlate for consciousness, Gerald Edelman hypothesized that hold on, I need to see if I have a picture. Yeah, Gerald Edelman hypothesized that consciousness was localized to the thalamocortical and limbic systems. 10 years later, Antonio Damasio claimed that consciousness was to be found in the frontolimbic nexus. So Edelman distinguishes between two types of immediate conscious awareness, primary and higher order. So there's another distinction of consciousness. Primary consciousness refers to the awareness of objects and their properties present in the world around us. So this is like content consciousness. Higher order consciousness refers to being aware that we're aware, right? That I can reflect on my internal mental states and draw conclusions about them. It's the middle model that we have of ourselves as a thinking, experiencing creature. He notes, this is Edelman, that the interactions of the thalamus and the cortex allow us to perceive things in the world around us. And when our thalamocortical system is connected to our limbic system, then we're able to assign valences and values to things in the world, right? So our limbic system, by and large, is a thing that tells us more than anything when we're scared of stuff. And so we can say, oh, this is very dangerous, don't go there. And it shoots that information up to the frontal lobes, which can then evaluate, decide what's there, and decide whether what the limbic system was screaming about was accurate. So Edelman claimed that there's a special reentrant signaling process that evolved in our cortical systems that permit us to connect memories of valued things with incoming perceptions in real time and in parallel across multiple sensory systems. And in fact, we know that there is that sort of reentrant system. The frontal lobe talks to the limbic system and vice versa. And with the advent of this special process that we developed when we developed our cortical systems, primary consciousness emerged. Damasio is very similar. He also postulates two types of consciousness: core consciousness and extended consciousness. And these, so far as I can tell, are exactly what Edelman means by primary and higher order consciousness, but everybody's got to have their same name for their stuff. So you're just going to have to like hang on. And like Edelman, but unlike Crick and Koch, he doesn't see consciousness as a single unified phenomenon. Also, much like Edelman, Damasio believes that the interactions among the limbic system, the thalamic region, and the cortical areas are the correlates for his core consciousness, which is Edelman's primary consciousness. Though he emphasizes different aspects of the structures, less importance attached to reentrant signaling, more importance to the contributions of the posterior medial cortex. In both views, the thalamic cortical system is key to understanding the neural correlates of primary or core consciousness. Okay, so very different perspective. So now they're looking at brain structures, not the way the brain, the individual neurons are kind of flapping about. And both Edelman and Damasio conclude that multiple brain regions underlie higher ordered or extended consciousness, because these are our self models. They have less detail to talk about these things because it's much harder to talk about. But it's very clear that whatever they think of extended consciousness or higher ordered consciousness, it's got to have access to many different memory systems, among other things. So it's going to be quite complicated. Okay, so as we come into this century, the researchers are suggesting perhaps the default network, which has been all the rage in the past, I don't know, 15 years ago, recently uncovered in imaging studies, might be central in the neural correlates consciousness of our sense of self. So this might be where extended consciousness is. Now, the default network, or sometimes it's called the default node network, is the interconnected areas of the brain region that remain active when a person really isn't thinking about or noticing anything. It's what's active by default. That's why it's called the default network. So what happened is, you know, they used to put, well, they still do, put people in MRI machines, and then you have some task, like you're looking at a flashing light, or you're trying to make a decision about a group of words, a group of letters. Is that a word or is it not a word? And normally what people do is they record at the start of the stimulus, and then they stop recording, or they stop looking at the recording when there's a response. And then they average all that together. And what they're interested in is, well, what parts of your brain is active when you're seeing a square? Or what parts of your brain are active when you're deciding something's a word versus deciding it's not a word? And then they can use that to kind of map out the different regions of the brain. It's a very smart way to proceed. But then they also realize, like, when you're just waiting, you're sitting in the MRI machine waiting for the next stimulus, your brain is not silent. It's going all the time. And in fact, they just started people putting in scanners and kind of lay there, just daydream, do whatever you'd normally do if you're waiting. And then they averaged all those signals together. And sure enough, what they discovered was there are very discrete areas of the brain that continue to be active as you're not doing anything. You're just daydreaming. You're just hanging out. So maybe that is, as we cogitate about ourselves, or we use our sense of self to do something, again, things get quite fuzzy quite quickly, but maybe the default network is important. But that's not the only proposal. Other proposals for the neural correlate of consciousness have included left hemisphere-based interpretive processing from Gazzaniga, global integrated fields from Kinsborn, an extended reticular thalamic activation system from Bernie Bars, intralaminar nuclei in the thalamus, Bogan, neural assemblies bound by NDMA, this is Hans Flohr, action, prediction, assessment loops between frontal and midbrain areas, this is Gray, homeostatic processes in the para-aqueductal gray region, this is Panksepp, and thalamically modulated patterns of cortical activation, Rodolfo Linnaeus. Okay, my point here is not that you retain any of this, it's that there's really no agreement among scientists or philosophers regarding what the neural correlate of consciousness might be, right? Everybody's got their pet theory. We seem to kind of coalesce around one idea that seems promising, and then maybe 10 years later, we flip to some other idea that seems promising. Nobody's got an answer yet. We got a lot of ideas floating around. Okay. More importantly, as these suggestions have piled up, we're beginning to realize that perhaps Crick and Koch were wrong in their initial assumption that there was a single brain mechanism that would account for all of consciousness. For each suggestion that I've outlined, really only attempts to explain how this hypothesized brain structure or activity gives rise to one aspect or other of consciousness. Nobody's trying to get the whole enchilada. They're picking and choosing if, you know, this brain activity seems to be aligned with this sort of conscious experience. So for example, global fields or transient synchronous firing assemblies of neurons, this is the Crick and Koch idea, might underlie our individual experiences, right? So you need to somehow join together the whiteness of the cup with the shape of the cup, with your conception of a cup, to recognize that what's in front of you is a white cup. But these are different areas of the brain that don't have a lot of crosstalk with each other. Visual perception, in visual perception in particular, color is processed separately from shape. And so it does seem to be perhaps that these oscillations are a way the neurons in effect communicate with each other, say, oh, we're oscillating together, we are of the same thing, and that allows our brain to recognize the object as an individual object. So maybe the 40 hertz oscillations or something like that helps us differentiate individual objects. And so it might be connected to our experience of the redness of the rose and so forth. But left hemisphere interpretive processes could explain our sense of conscious self-awareness over time. And the reticulating activating system could help account for a background sense of alertness. And it's possible that each of these distinct neural theories are true, with each contributing to some partial explanation of the full complexity of consciousness. So despite Crick and Koch's initial assertion, there's no reason to think that consciousness cannot be realized in various locations or by utilizing a number of different mechanisms. And so perhaps there's no single correlate of consciousness at all, but we should be looking for several different neural mechanisms to account for the full range of conscious phenomena. So I want to pause here just for a moment to let this sink in, because what this is suggesting is consciousness is not one thing, as much as it may seem that way from inside our heads, but rather it's a multiplicity of different things, each of which is going to have its own little explanation. So being alert is actually something very different than seeing and recognizing the white cup as a white cup. So instead of looking for the neural correlate of consciousness, perhaps we should seek the neural correlates of consciousness, the NCCS. The complexity of what the brain might be doing that differentiates being conscious from being not conscious suddenly becomes enormous. A better research agenda then might be to investigate different aspects of conscious awareness, looking for the different NCCs that underlie each one. So, and this is true with a lot of scientific projects. People think, oh, this is going to be really simple. I'm going to get consciousness figured out before dinner and be done with it, because it's just one simple thing. But then once you start getting into the details, you realize, it is actually very complicated. And maybe we should break this down into smaller chunks and examine each chunk until we understand it thoroughly. And then maybe we can put everything together into a grand global theory of consciousness, but maybe not. In hindsight, simply assuming that an NCC, that there is one NCC, seems to be theoretical overreach. And yet, even if we adopt the more sophisticated approach for identifying underlying brain activities or processes associated with different aspects of consciousness, there's still several troubling problems with this putative research agenda. So I'm going to kind of go a little bit quickly through these problems, because I believe you've probably covered them in one guise or another already. throughout the other conversations. So some problems with looking for the NCCs. So consciousness is often being described as completely puzzling. Colin McGinn is famous for this. He refers to it as a residual mystery. Such a description is completely understandable because of consciousness' ill-defined boundaries. Its fully subjective character, the vividness of our phenomenological experiences, and perhaps most importantly, the complete opacity of its purpose. Like, why are we conscious at all? Nobody has a good answer for that. What does being conscious do for us as organic mammals? We don't have a good answer for that either. Or what does it allow us to do? We don't have a good answer for that either. For any particular human activity, it certainly seems that we, or maybe a computer, could do the same task without being conscious. And indeed, for many human abilities, we do have machines that can mimic us successfully, or sometimes even better than we are. So this hazy status of consciousness in relation to human thought and behavior raises questions regarding its relation to the science of psychology or neurobiology. Like, how is this supposed to connect to scientific endeavors, given that we don't understand what it's doing there for us at all? And so I'm going to look at two of the problems that kind of float around this general environment with the frustration of a scientific investigation of consciousness. One is the explanatory gap, and the other is the so-called hard problem of consciousness. So the explanatory gap, which dates back to Levine in 1983, is the name given to the inability of physical theories to fully account for the phenomenology of consciousness. So any scientific account of consciousness that you have, 40 Hertz oscillations, intralaminar interactions, cortical thalamic processing, any brain theory about the NCC faces the problem of explaining how the rich technicolor of conscious phenomena just is, or is the product of some non-experiential physical interaction. Like, what about 40 Hertz oscillations gives rise to the sensation of redness? That's a huge gap. So saying something like the experience of the color red is just the coherent oscillations of such and such neurons in area B4 says nothing about how these oscillations give rise to that feeling of seeing red. While the experience of the color red might be correlated with the oscillations, that's not the same thing as them being reducible to or identical with the oscillations. So any putative reduction of consciousness to any physical interaction seems to leave out the very thing it wants to explain, namely the conscious experience itself. So there's this necessary gap in any putative scientific account of consciousness and its target for explanation. Whoops, sorry, I need to go back. And this creates problems for people like Crick and Koch, who believe that identifying the NCC is going to provide a theoretical explanation for what consciousness is. If there is an explanatory gap, it will not really help us to know that coincident oscillations in the brain co-vary with consciousness, for example, because brain oscillations are just too different a thing from a conscious mental state. We don't have an intellectual bridge or a theoretical bridge from one to the other. And without such a bridge, knowing about these sorts of covariations is not going to be explanatorily helpful. And if it's not explanatorily helpful, then it's not going to provide a good foundation for a scientific theory of consciousness. Discussions of the explanatory gap come in different degrees of severity. Some think the explanatory gap is kind of a practical inability of our current scientific theories. We just haven't figured it out yet. In principle, it might be possible to bridge that gap, but our current theories aren't there yet. Others agree that it's in principle possible to bridge the explanatory gap, but we are too stupid. We are never going to get there. So maybe from a God's eye perspective, you can understand consciousness in the sciencey way, but not using weak human brains. Because we're just lacking in whatever cognitive capacities required to close that explanatory gap, to see how these things give rise, how one thing gives rise to consciousness. And dualists primarily believe the strongest version, like you can't do it through science. So I see the explanatory gap, the hard problem of consciousness, really as the other side of the explanatory gap coin. They're both different versions of the same issue. The explanatory gap refers to the putative impossibility of consciousness, putative impossibility of accounting for the subjective experiences by physical theories, and the hard problem of consciousness asserts that physical theories cannot account for why subjective experiences exist at all. Proponents of the hard problem argue that science cannot account for why some systems are conscious, but others are not. The hard problem of consciousness assumes the veracity of the explanatory gap. In other words, if the explanatory gap is true, then we have the hard problem of consciousness. Now, David Chalmers articulates the issue in this following way. What makes the hard problem hard and almost unique is that it goes beyond the problems of the performance of functions. To see this, note that even when we've explained the performance of all the cognitive and behavioral functions in the vicinity of experience, perceptual discrimination, categorization, internal access, verbal report, there are still many that remain, there still may remain a further unanswered question. Why is the performance of these functions accompanied by experience? Even if all of science is completed, he thinks there will always remain the further question of why some systems in science, why some of the systems science has explained are conscious, in addition to whatever else it is that they do. So we can explain maybe visual perception, starting with the eyeballs, going all the way back, having it bounce around in the head, ending up in the frontal cortex. We can explain all of that, but we can't explain why there is this accompanying experience of visual perception. Chalmers believes that such a question cannot be addressed in physical terms, otherwise we would have already done it. Therefore, consciousness has to be something non-physical. Others believe that the hard problem is just that, it's a hard problem, and it doesn't make any further claims about the metaphysics of consciousness. So these two problems affect consciousness studies in general, but the problems are especially relevant for neurobiological approaches to consciousness and hypotheses about the NCC in particular. The challenge for NCCs raised by these two problems can be understood at operating at two different levels. On the one hand, it's possible that no NCC could ever account for the whole phenomena of consciousness. That's to say, after finding the neural correlate for some specific subjective experience, we still will not be able to know why it is that particular experience feels that particular way. Even if we have a well-constructed and refined theory of the neural correlates of consciousness, it may never completely explain what we care about with respect to phenomenological experience. On the other hand, NCCs may simply be the wrong approach to explaining consciousness. If the subjective experience of the color red or any other qualia really is non-physical, then seeking their neural correlate seems to be a task without a purpose. So most advocates for trying to identify the NCCs have very little patience with either of these two alleged problems. They see the arguments as some sort of exaggerated reasoning from oddness that many dualists have, kind of an intellectual hysteria, as it were. In particular, they believe the proponents of the explanatory gap and the hard problem just don't understand how science proceeds. A lot of science tackles really strange things, and many of its explanations are counterintuitive and frankly, intellectually unsatisfying. Quantum mechanics, in particular, can be like this. And that some people now cannot see how a biological theory of consciousness could account for the raw feelings of phenomenology is not a strike against biology or a victory for the consciousness mysterians. Rather, it says something about those folk. Perhaps their inability to see how 40 hertz oscillations just are a conscious visual experience points to a failure of imagination on their part and not a failure of science per se. But more importantly, I think, is that science is in the business of seeking correlations. So let's take an example. Smoking is correlated with lung cancer. And physiologists can dig into the chemistry of cigarette smoke and the biological composition of lung tissue to help flesh out this correlation. We learned that benzoaprine, it's a chemical found in cigarette smoke, is correlated with damage to DNA. And chromium, another chemical in cigarette smoke, is correlated with benzoaprine sticking more actively to the DNA. And arsenic, yet another chemical in cigarette smoke, is correlated with slower DNA repair processes. But it's just correlations all the way down. Some of the correlations we call causes to emphasize their importance in the ultimate story, but all scientific investigations could ever give us are a series of correlations. And then we can turn this series of correlations into an explanatory narrative. The chemicals in cigarette smoke cause cancer because benzoaprine damages our DNA, while chromium helps benzoaprine stick to our DNA, which increases the amount of damage done, and arsenic prevents the DNA damaged by benzoaprine from repairing itself. And it's this narrative of a series of correlations that gives us the satisfying sense of a good explanation. But it's still just correlations. But it's very, very difficult in a pre-narrative state to argue that any possible story about how something comes out is just not going to work for us. We have to start with the correlations and then build from there. And any science of consciousness follows exactly this pattern. Perhaps we find some correlations in the data, in the brain, between neural activity and consciousness. Neurophysiologists can dig into these correlations to learn more precisely what's correlated with what. Then we can turn them into an explanatory narrative. There's nothing difficult about consciousness that makes its science suspect or more difficult. The only thing that's different is that people can't see how the narrative might go before we have the correlations. But I dare say that this has been true for a lot of things we have had explained, like the plague before we knew about bacteria, or fire before we knew about oxidation. Who could have antecedently imagined germs or invisible chemical reactions before we uncovered correlations that indicated these things existed? At best, right now, we can say, or I'm going to say, science should do its work. And then later, we can see where we stand with respect to moving from the NCCs to a story about where consciousness comes from and what it is. I mean, it could be that we will never be able to develop an intellectually satisfying neurobiological explanation of consciousness. But even if we cannot, it is unclear at this stage in the game whether this would be because consciousness falls outside the realm of what science can explain, or because we failed in our scientific endeavors, or because we don't like what science is telling us. So in the last section, I want to talk about embodied approaches to neural correlates of consciousness. It's a different sort of problem for understanding NCCs, and it comes from the positions that are purely materialistic, but they're not brain-centered. And I'm speaking of embodied cognition approaches to understanding the mind. Embodied cognition refers to a wide range of theories of cognition that assume that any explanation of cognitive processes will also have to reference both the body and the environment. So you just can't do neuroscience inside the head, as it were, and really understand human cognition. As such, embodied cognition approaches As such, embodied cognition approaches challenge brain exclusive explanations of cognitive phenomena. And this movement in philosophy and psychology really started in the late 1990s with Andy Clark, who highlighted the relevance of body and environment for cognition. And they used this original demonstration. First, they challenged students to do a difficult multiplication problem. For example, each multiplicand is 10 digits long, say. Do it in your heads. And that's hard. It might be impossible. It'd be impossible for me, for most math literate students to do this successfully. But then they propose the same challenge, but this time they get to use pencil and paper. The task suddenly becomes much easier. What's different between these two tasks? The math problem is exactly the same. What changes are the resources available to accomplish the assignment. If a pencil, a piece of paper, and a hand to write with are all crucial for accomplishing this cognitive task, then it would seem that any explanation of mathematical ability requires more than simply a description of brain activity. So proponents of embodied cognition believe that these sorts of examples demonstrate that that body and environment have to be included in our explanations of the mind. For our minds can only function in our particular bodies interacting with our particular environment. And so we need to understand our bodies and our environment in order to understand our minds. And I'm sure, even if you don't think much about math, you're aware of this phenomena if you're a certain age, that is an age before cell phones were a thing, when you had to memorize everyone's cell number. And I'm embarrassed, but only slightly, to admit I do not actually know the phone numbers of my children, whom I do love more than life itself, but I don't know their numbers. Why? Because I have my cell phone, which remembers them for me. And so I have offloaded those mnemonic tasks to information systems around me. And that's the point that proponents of embodied cognition are keying into. So consciousness seems to be a cognitive phenomenon, at least in some parts, and as such, perhaps therefore, it should be considered embodied. So this means that the NCCs alone will not suffice in explaining subjective experience. For defenders of embodied cognition, as much as we have to appeal to pencil and paper and a hand in offering a complete explanation of the cognitive processes behind multiplication, we would also need to appeal to the relevant aspects of body and environment in order to offer a complete explanation of consciousness. Here, NCCs might form some part of a scientific theory of consciousness. They could potentially help us understand connections between bodily action and conscious experience, but in and of themselves, they're never going to be a complete explanation of the phenomena. For example, we have data concerning the neural correlates of consciousness in action. So increased activity in posterior parietal cortex, which is tied to our intending to move and our picking up and our picking which action we want to select, is correlated with our experiences of motor execution in the environment. So when surgeons gently stimulate Brodmann's areas 39 and 40, which is part of the parietal cortex, in awake and alert patients, and they do this when patients are undergoing brain surgery to make sure they're not going to wipe out something that's really crucial, they go and poke around first. Patients report experiencing the intention to move. And often they experience illusory movements themselves. That is, they are experiencing themselves actually moving when in fact they don't. And then when the electrical stimulation increases more, they believe they actually have moved, even though there's been absolutely no neuromuscular activity. But in contrast, when surgeons stimulate the premotor region, the area of the brain associated with actual bodily movements, that is, that's the part that lights up when you do something physical, patients have no conscious awareness of any action, even if they really do move. So that's one example that someone might take about neural correlates of consciousness for action. So interestingly, our conscious experiences of action seem to be independent of the physical movements themselves. Instead, we become aware of intentions to move just slightly in advance of the movements themselves, and these experiences double as our experience of the movement itself. So conscious awareness seems to co-occur with intending to move purposefully in the world instead of actually moving. That is, consciousness, or more accurately, some aspect of consciousness, might be correlated with our planning how to move our bodies in our current environment. So if embodied consciousness is the right approach for explaining cognition, then we are left with two questions for explaining consciousness. First, what are the relevant features of body and environment that would be included in a complete theory of consciousness? And second, what kind of descriptions and methodologies should be used to integrate neural correlates of consciousness, the body, and the environment into one explanation? So I want to explore these two different approaches quickly in answering these questions using embodied perspectives. On the one hand, there's neurophenomenology, and on the other, there's the extended conscious brain approach, also known as ECM. As I said, people like their own names for things. So the first supports the project of identifying the neural correlates of consciousness. The second does not. So Francisco Varela in '96 first proposed the idea of neurophenomenology, which combines first-person reports of conscious experience with the neurophysiological approach normally used in NCC research. So neurophenomenology integrates phenomenological and neurophysiological investigations of conscious experiences with each other, while at the same time trying to make explicit the relationship these two methodologies have to each other. So phenomenology itself has a long and multifarious history in philosophy, starting with Edmund Husserl in the early 20th century. But the basic idea behind phenomenology is that it's a rigorous examination of the structure of conscious experience as experienced from a first-person point of view. The expectation is that all first-person experiences have some invariant features, things that are common to all conscious experiences. And identifying these stable features is the ultimate goal of a phenomenological investigation. The neuro of neurophenomenology refers to a physiological account of consciousness, the same as the NCC project. But proponents of neurophenomenology put a twist on the basic NCC assumptions. The classic Crick and Koch approach to NCCs is unidirectional, moving from neural activity to conscious experience, right? You build up, it's a reductive approach. You build up from the brain to the conscious experience. That is something about a particular set of neurons or their interactions or something like that causes consciousness to occur. But neurophenomenologists believe that neural events, which are embedded in bodies and their environments and conscious states, exist in bidirectional or reciprocal relationships. Conscious states emerge from brain-body world interactions, and they in turn constrain what the brain and the body can do in its environment. Neurophenomenology describes NCCs as part of a larger and more complex system that accounts for consciousness as a whole. Using embodied approaches to consciousness in general, and neurophenomenology in particular, means that consciousness has to be understood in terms of brain-body environment interactive systems, with each component constraining and being constrained by the others. Any complete explanation of a conscious experience will have to integrate elements across all of these different elements, showing how they are all connected to one another. So classic conceptions of NCCs as the things in the brain that are the only things that are correlated with conscious experience are completely wrong-headed. NCCs are likely to be included in any explanation of consciousness, but a complete explanation will have to take into account other aspects of both the body and the environment. In addition, neurophenomenology requires that aspects of the body and the environment that play a role in conscious experiences are constitutive parts of the experiences themselves. The core idea here is that unlike more reductive accounts of consciousness, both body and environment are causally relevant for consciousness. Both body and environment are part of the mechanisms of consciousness, just like NCCs are. There is a multi-directional causal relation between NCCs, the body, and the environment, with each affecting the others as the others are also affecting each. A consequence of this view is that how to articulate what the NCCs are is likely to be extended in space and in time, as the usual ways that the body and the environment affect neural firings in the brain is through very particular neurosensory and neuromuscular junctions. In general, according to proponents of neurophenomenology, the way to understand the underlying physiology of consciousness goes as follows. A localized neural brain state causally affects a large-scale neural dynamics, which then causes the body to move, which impacts the environment, which also changes the sensory inputs, which affects the large-scale neurodynamics, which also changes the local neural states. So a full explanation of consciousness has to account for all of these different types of interactions and the multi-directional relations among them. Excuse me. Perhaps most importantly, though, phenomenology provides a phenomenologically precise first-person data produced by employing first-person methods, provides strong constraints on the analysis and interpretation of the physiological processes relevant to consciousness. That is, we need our subjective descriptions of conscious experience to help us interpret what's happening inside the brain. Perhaps too, as we use our first-person descriptions to inform our neuroscience, then the third-person data produced in this manner might eventually constrain first-person data, so that the relationship between the two would become one of dynamic, mutual, or reciprocal connections. So the methodology of neurophenomenology is bidirectional as well. On the one hand, using a phenomenological analysis, subjects will provide refined and precise reports of conscious experiences to researchers, which could provide important details that otherwise might be glossed over. Such a practice might describe distinctions between two similar conscious events that would have remained unnoticed without this type of analysis, for example. This then might improve the analysis of the physiological data, as the target of investigation would be clearer. Small differences in EEG results, for example, could gain new meaning if small differences in conscious experiences were articulated. On the other hand, a more detailed physiological analysis of the NCCs might constrain additional phenomenological analyses of the conscious experiences. So, for example, by understanding the changes at the neurophysiological scale, subjects might be able to understand their own conscious states better or see new distinctions among them. So not only could the phenomenological analysis of conscious events lead to a better understanding of the physiological results, but improved physiological analysis leads to a better phenomenological interpretation of consciousness. And it's this bidirectionality of theory and methodology that's the cornerstone of neurophenomenological approaches to understanding conscious experience. So let me give you a concrete example. Focal epileptic seizures start in a specific part of the cortex and then remain confined to that area, or they spread to other parts of the brain. Where the seizure originates and how it spreads determines the symptoms of the seizure. Often these symptoms include changes in the conscious experience of the patients. Patients with epilepsy often experience auras or sensory hallucinations, usually visual auditory, but sometimes olfactory or gustatory, at the onset of the seizure. Temporal lobe seizures can also result in the experience of familiarity or déjà vu. Walter Penfield discovered that stimulating small areas in the temporal lobe also causes this experience of familiarity. It follows that activity in the relevant areas in the temporal lobe is relevant to the experience of familiarity. This local neural event helps account for a global sensation. The converse appears to be the case as well. We know that both bodily states like stress or lack of sleep and the surrounding environment like flashing lights can trigger seizures in those with epilepsy. About half the patients with epilepsy experience warning signs like headaches, nausea, irritability, and that tells them that a seizure is imminent. Scientists are now able to align these symptoms with changes in the global dynamics of brain activity, as well as with changes in bodily states in the environment. Importantly, it appears that some patients can use these experimental and environmental cues to decrease the probability that they're going to have a seizure by using biofeedback and classical conditioning techniques. So the patients are using global parameters, including their own insights regarding their conscious experiences, to affect local neural events. Neural phenomenology seems to articulate the way the science of consciousness actually proceeds. This is apart from what philosophers think. This is like what's really happening on the ground. So as the examples I've shown you, scientists who study aspects of awareness spend their time measuring behavior and environmental events, as well as how the brain changes, and they try to account for how they all impact personal experiences. Philosophical analyses of neurophenomenology help clarify the importance of accurate and full first-person descriptions of experiences, and I hope we'll be able to see its influence in seeking the neural correlates of consciousness going forward. So these are all examples, I think, of people taking a neurophenomenological approach to understanding the neural correlates of consciousness, whether they recognize that's what they're doing or not. The other dominant embodied approach to understanding consciousness is embodied conscious mind, and Alvin Noe is one of its main proponents. He argues that for at least some experiences, the physical substrate of the experience may cross boundaries, implicating neural, bodily, and environmental features. The main thesis of ECM is that consciousness itself is not exclusively located at the neural level, but it crosses boundaries at the body-brain environment system. Notice that this is a more radical position than neurophenomenology, which remains agnostic regarding where consciousness resides exactly. Neurophenomenologists believe that brains, bodies, and environments are all necessary for understanding what consciousness is and how it functions, and that there's a causal bidirectionality between experiences and neural states, but most are perfectly comfortable with the idea that particular brain states or activities correlate with particular conscious experiences. It's just that the brain states or activities come about via an interaction with other experiences, bodies, and the environment. ECM, by contrast, holds that the correlates of consciousness themselves run outside the brain. Neurophenomenologists believe that some version of NCCs exists, but ECMers explicitly deny that there is such a thing as an NCC. We can understand ECM as a particular instance of the extended mind thesis in general. Just as pencils, papers, and hands comprise part of the cognitive process of multiplication, so too do bodies and the environment comprise part of conscious experience. From the extended mind perspective, these external or non-neural objects constitute, at least in part, the very physical substratum of mental states. So one way to appreciate the ECM perspective, because it does sound a little strange when you first start talking about it, is to consider how we project ourselves through objects in the world. So a blind man using a cane, for example, does not experience the cane while he taps his way down a sidewalk. Rather, he experiences the world at the end of the cane. Similarly, when we write with a pencil or a pen, perhaps when we're doing multiplication, we feel the end of the pencil writing on the paper, even though, of course, our nerve endings don't extend through the end of the writing implement. We're projecting our bodily awareness through the end of the pencil. Or when we walk in shoes, and I can say as a woman who often wears high-heeled shoes, this is very true, we feel the pavement below us. We don't feel the inside of our shoes. We feel the ground. And we do this because we are projecting ourselves through our shoes. So proponents of ECM say that the cane, the pencil, and the shoes all become part of our conscious system. And we can measure the edges of the conscious projections experimentally. For example, Tony Chimero and his colleagues devised an experience that forces change in our extended conscious experience. And here's the setup. Undergraduates engage in a very simple video game using a computer monitor and a mouse. And at irregular intervals during the trial where they're trying, can't remember what they're trying to do. I think they're trying to herd dots into a particular corner of the screen. The connection between the mouse and the monitor was disrupted. And when students were engaged in the video game, they were not aware of the hand-mouse interface per se. But when the connection between mouse and monitor were altered, then the mouse grabbed their attention and they became aware of it. So once the disruption was over and the connection returned to normal, then the awareness of the hand-mouse connection disappeared. They just became one with their mouse, as it were. Chimero and his colleagues argue that during the normal phase of the task, the mouse was part of the conscious system. During the disruption, it was not, because the projection stopped, at the edge of the mouse, as it were. So the details of this would take us too far afield. They're able to measure the changes and the underlying behavioral dynamics that reflect the changes in conscious experience. Their point, though, is that we project ourselves into the environment, and in so doing, we consciously experience the edges of our extended cognitive system, which is always fluctuating as our body interacts with the environment. So the remaining question for ECM is how this might relate to putative NCCs. Most proponents of ECM accept that the role neural states play in consciousness is fundamental. You got to have a brain. Although there are some radical embodied approaches to consciousness that deliberately and explicitly avoid any appeal to brain states as an explanatory tool, and Chimero is one of them. They take ECM as a theory that may account for some or most conscious experiences, although they agree that there are some other experiences that might be purely internal or brain dependent, like a headache. So most proponents of ECM are not going to say the headache is necessarily a product of brain-body environment. It might be causally related, but the headache itself is localized inside the head. But as Ken Pepper points out, the way in which ECM relates to NCCs is different from the way the extended mind thesis relates to brain states in general. According to the main proponents of the extended mind thesis, external objects constitute mental events when they're used in the same way that we might otherwise just use our brains to achieve the same end. Using a pencil and paper might help us do a multiplication problem, but the pencil and the paper are substituting for what our brains could do if we had to do it. Like I could remember my children's phone numbers if I had to, if I no longer had a cell phone. So the cell phone is just substituting for what I can already do. But consciousness seems to be slightly different. It's difficult to imagine an extension of a conscious event in functional terms, right? When we project ourselves into the environment, we're not substituting something external for some internal process of consciousness. Conscious experience is not extended into the environment by causally replicating what we might do internally, but it's the experience itself that is constituted by whatever it is we're projecting ourselves through. In this sense, consciousness extends beyond the brain by its very nature. This is what ECM people think. And if this is the case, then there's no NCC. Conscious experience is not constrained by those sorts of bodies we have and the types of environments we're interacting with. Rather, consciousness is located out in the world just as much as it's located inside the head. Now, of course, there are several people who flatly disagree with this perspective and argue that proponents of ECM confuse constituency with causal relevancy. That is, if we lost significant portions of our brain, we could thereby lose consciousness. However, if we lose significant portions of our environment, our ability to perceive the environment, our ability to interact with the environment, even if we lost significant portions of our body, we could still be fully and richly conscious. And this reminds me of the anti-war classic, Johnny Got His Gun, where there was a person, lost arms and legs and vision, hearing, and so forth, but he was still richly conscious. So the point is, some things in the brain-body environment complex are more relevant for consciousness than others, and the search for the NCC is a search for those things most relevant. So most people who are looking for the NCC, not surprisingly, even if they believe in embodied cognition, say the brain is fundamental to the conscious experience. Okay, so Crick and Koch articulated a very simple vision for how to investigate and understand consciousness. You just got to isolate the thing in the brain that's correlated with experience, and boom, you've identified what consciousness is. But unfortunately, it turns out that whatever story ends up being told about consciousness, it's going to be much more complicated. Already, we can see that there's not going to be a single thing that accounts for a wide variety of conscious experiences. Probably, we're going to have a different neural correlates for different aspects of consciousness. In addition, it seems naive to believe that we can understand our brain or our minds in isolation from the bodies they're housed in and the environments in which we live. So understanding consciousness is at least going to require matching changes in brain activity with changes in its surroundings and vice versa. So at the end of the day, it remains to be seen whether syncing the neural correlates for consciousness is a productive approach for understanding our phenomenological experiences. So before I close, I just want to give a shout out. They mentioned earlier that I was the editor for the Journal of Consciousness Studies. Now that you've gone through this course, you might want to check with your library or online for the journal. It is a multidisciplinary journal. It is written by academics, but the goal is to try to communicate whatever is being written about to non-experts. So we can't have the neuroscientist interested in this, only talk to neuroscientists, but rather talking to people who are very interested in consciousness itself. And the journal is in English. So I will stop here, and I'm most happy to take any sort of questions or comments that you might have.
Thank you so much, Valerie, for that presentation. That was quite an extensive and neurological account of the neural correlate, but put in a very simple and approachable way. So thank you so much for that, Valerie. Shantina, I don't know if you had any comments on this presentation.
Oh, thank you. Thank you very much, Valerie, for a beautiful presentation. I've certainly many questions, and I'll throw some of them out, and I don't want to take too much time for other people questions. But one question is, would you say that consciousness is in some essential way related to action?
Well, that's a hard question to answer. on the one hand, it seems like when we try to reflect on what the heck is it for, it does seem to be related to our ability to get around in the environment. So we consciously hear a noise, we recognize a gunshot, we know we need to duck or seek shelter. So there seems to be that connection. On the other hand, I can sit quietly for hours and have a very interesting internal mental life, and I am not needing that to do anything in particular in my environment. So if I had to guess, and if we're taking the view that consciousness, it is a biological phenomenon, I would say it probably evolved relative to action, but it's no longer, that's no longer its sole purpose, I would say.
Thank you. Thank you very much. And let me throw a few more, or at least one or two more questions. What's your take, or what's the take of this view, like extended conscious mind, on free will?
Oh yeah, so my honest view, and it's very easy, is that from a science perspective, there is no such thing as free will. It is an incoherent position if you believe in causes, because either something is caused or it's completely random. And if it's caused, then it's not free. And if it's completely random, it's not really free either. So I think if you want to take a science perspective, you're locked into saying there's no such thing as free will.
Even if you consider that quantum phenomena may manifest on a macroscopic scale?
Yeah, well, again, if it's something that's relatively random, so it might be constrained prediction, but it's still unpredictable in that way, that's not generally what we mean about free will, right? Because when we're talking about we do something from our own free will, we don't mean it's like an epileptic seizure, we just did it randomly. Rather, we mean we could have done something else had we chosen to do that.
Well, that kind of implies the idea of an I, that there is somewhere.
Well, it depends. You can
Subject.
Yeah, right. Or, I could say my mental model of myself, that is the decider, did this. I will just shorten that to say I.
One last question. Is there any connection between this approach, these approaches, and panpsychism?
No, I don't think so. And I say that because all of these approaches really have an animal at the center. Even the most radical positions of the extended conscious mind have a person in the middle. And so for that reason, I would differentiate it from most panpsychic views, which really, from my perspective, the way I think about it, believe that there are things outside humans or animals or mammals that are conscious, and having an animal interaction is not required to be conscious. So I think it's different.
Okay. Thank you, Valerie. And maybe I'll give the word to people who certainly have many interesting questions for you.
Sure.
Thank you, Shantian. And yeah, quite hard questions there. Free will, panpsychism. But yes, let's open it up to our participants. As I said earlier, to ask a question, either use the raise your hand function on the reactions, or physically raise your hand, or if you're feeling shy, you can just write your question in the chat and I'll read it out for you. I believe the first question will come from Valjean.
Hi. Thank you. I really love this presentation. Thank you so much. Really, just wonderful. I was curious, yes, and your sense of humor. Had lots of laughs during it, and I think a lot of understanding, and then complicated things that we certainly don't understand. But I was thinking that memory plays a big role in this. And for example, when we learned how to ride a bicycle, beginning we had to figure out, how to put our foot over the frame and then get on the pedal and then move forward so you could retain the balance and things like that. And then later it just becomes automatic. Then I was thinking, when I was a teenager memorizing a piece of music, a teacher told me, your memory's in your fingertips, it should not be there. And I thought to myself, no, my memory is the sound, I hear it in my head, and then I put my fingers back on the place, whereas I couldn't just go back to where he wanted me to begin the piece of music. I had to go back where my fingertips knew it, and then I could continue. Okay, that's a different thing, but my question really is, why is NCC an either or with EMC? Wouldn't it be a combination of both?
Well, yes. I think people, I think there's a philosophical difference that would engage the philosophers who care passionately about the NCC and those who care passionately about EMC. But for people who are not in that debate, they don't care, because the proponents of NCC would say, once we've identified whatever it is that's going on in the brain, now we've explained consciousness, we've got it. And they'll agree, yes, but of course the brain is embedded in a body that interacts with the environment, and we need body environment interactions to get the twitches in the brain that give rise to consciousness. But it's the neurons that are important. Proponents of the extended conscious mind would say, no, philosopher NCC person, that's not right, because there's no way to have a conscious experience without having your body interact with the environment. And so just as the pen becomes, something that I project myself through to write on my paper, you're going to have to include it in your theory. It's going to be fundamental to your theory. And so the NCC is not just going to be localized inside the head. But I do agree with your intuition that this is a picking of nits that most people are not going to care about, because it is a difference in emphasis and a difference in maybe a perspective on how you think the ultimate explanation will go. But of course, we're not there yet. So now we have the picking of nits. And so I also want to just comment briefly on your comments about memory and learning and the experience that we have when we're learning things. And I think it's tied very closely to attention, because as we become proficient at doing something like speaking or riding a bicycle or driving a car, we can only really do those things successfully and smoothly if we don't pay attention to them, right? We're aware that we're doing them, but the second you start paying attention to riding your bicycle, you kind of start wobbling around. And that's a very interesting phenomena, the way learning works in the brain, because what it looks like is we need our attention, we need our conscious focus to learn new skills, but the goal is to get them out of our attention. The goal is to make them automatic. And I think that I didn't talk about it today, but I think that creates a really interesting perspective on consciousness, whereas its goal in some sense is to get rid of itself. The less you're paying attention, the less you're aware of, the more successful you are at engaging in your environment.
Yeah.
That's very interesting. Yeah.
Thank you very, very much. Thank you.
Thank you, Valerie. And it's actually really interesting about this, what you've just been talking about, because yesterday Gary Lackman was talking about Conor Mosen's account of the robot, which is sort of that running in automatic. Now, of course, Gary was talking more an existential point of view rather than a neurological, but the point is still very similar. Yes, so next question we'll take from Joy.
I would like to understand the connection with the feeling body and what you're talking about. I think you kind of touched on it, but I didn't quite get that.
Can you say a little bit more about what you mean by the feeling body?
Well, along with awareness, there's often a feeling. I don't know if it's really separable from, I guess, what we call intuition. So I think for me, it's like this broad term consciousness is a bit unwieldy, and it's kind of like the Eskimos have I don't know, 1,000 words for snow. We've got one,
Right.
3 words for consciousness, and we need to get like, 97 more. But anyway, I just, I don't know. Does that?
Yes,
So
right. And I don't have much to say, except I think I completely agree with your perspective. And so when you're talking about feelings, just simple emotions, joy, sadness, never mind intuition, because I don't know how to think about that, hunger, all of these bodily states, they do seem to be, not only are they interior states that we're perceiving as opposed to exterior, I would not be surprised that they're not somehow fundamentally different than, what's going on in our brain when we feel sad is just going to be different than what's going on in our brain when we're looking at our coffee cup, unless we're sad that our coffee cup is broken. But I agree. And I think if you really want to study the neural correlates of consciousness, you would be very wise to pull these apart and just start small. Don't try to do the whole thing like Chris and Koch did at the very beginning. We're just going to do a grand theory of everything. We'll get it popped off in this 10-page paper, but rather start small and pick off something and chew on it and really understand it, and then try to see how that connects to everything else. I think that's the most important way to proceed. And in fact, like one of the things that we've learned, we always knew, but now we're really learning it. And you can see it in all these conversations about the microbiome and what's going on in our guts, right? So a lot of your brain is actually in your stomach. We have neurons down there that feed directly into your brain. And that's why you get butterflies in your stomach when you're nervous and scared and things like that. And so I think we're just now starting to get a sense of how complicated things really are, how interconnected they might be, and how all of this then impacts how you experience the world around you.
Mm-hmm. Thank you. I have one more question, if that's okay. Okay. So right now there's a lot of talk in the US about these UFO sightings that have been verified by the government. They still don't say they're, like from other extraterrestrials, but just that it's unknown technology. So I'm just wondering, because then this made me think, well, when humans do go to other planets, and now they're talking about taking humans to Mars, how is that going to affect our consciousness? If it's a part of the environment, are we just going to become like really different? Just wondering.
Yeah. So kind of funny you should ask. This is true. My sister is an astronaut, Shannon Walker, and she just got back from space. She's been there twice. So I've talked to her about these things. Not in the sense, well, if we go to a really foreign world, what is it going to be like? Because that quickly goes off the rails, at least with a conversation between the two of us, because she's a physicist and, we're very science oriented. And it's like, well, what are the parameters we're talking about here? And then just, no, it doesn't work for us. But it is very clear, even when you're in a weightless environment, things change in ways that we don't think about on Earth. For example, we actually have a very strong sense of up and down, and we rely on it all the time. But in space, when you're on the space shuttle, there is no up and down. And in fact, they stop when you're first there, she says, you still kind of have a fake up and down, right? You kind of arbitrarily decide some part of the spaceship is up and then the opposite side is down. But pretty soon that just goes away and you no longer have any sense of up and down. And that really seems to affect how you perceive the world. And then it's very distressing when you get back on Earth and all at once there is an up and down because you stopped using it for months. And so that's just kind of a little silly example. But I do think that as we go into stranger environments, that it does impact how we perceive and experience the world. Not only are we going to be perceiving and experiencing new and different things, but we'll probably be letting go of things that we perceive and experience here on Earth.
Interesting. Thank you.
Thank you, Joy, for your questions. We'll take, I don't know, Niels, I saw you had your hand up. I don't know if you still wanted to ask your question.
Yes, I'll continue a little bit in my groove, because I have something that could actually be quite helpful to all these exercises, trying to understand what the brain is. I have for many years modeled network with neuroscientific ways of doing it, especially within movement. People moving in space, and each given their own consciousness and awareness of what other people are doing. And so, but what is the amazing thing about this is, that's why I'm here, is that, boom, I was looking for someone with a similar idea, and I found Boom with his wholeness and implicate order. And that, having now looked into what the brain structures look like, I can see that there's, if you take an environment, it's like a huge network of interconnections of people and places and roads and places you can walk. But the crucial thing is that we have Boom's idea of wholeness and implicate order. And the implicate order is, in fact, like the backprop that they're using in artificial intelligence. And you can experience that. They know that the backprop is necessary for learning and all the other things. But it turns out that it actually is the cause of wholeness in a very, however complex the network is. I won't say anything more than this, but so already in this model we have the idea that of consciousness, and so I've been trying to formulate what consciousness is, and that it's to do with action. So if I might perhaps propose that consciousness is a state which induces action. So consciousness, you're conscious of something, and then your action is to make the best out of what that is. If you see color and things, we all experience different ways of interpreting things that we actually experience. And I've had friends who see colors instead of hear music and that kind of thing. So, but what is exciting to me is really that we have something that can model all these parallel functions in the now. So if we want to model everything that's going on with all, we can be conscious of our fingers, and when we learn to play the piano, we get to the point we don't even think about what we are doing. We can just sit and watch the fingers moving around under. So, and I've studied David Chalmers also. So I think this everything at a glance is really in a irreducible way. I think that is what he's asking, because he believes that has to do with consciousness as well, if I remember right. So so this is disruptive, but with one day I might give a talk about this, but if I could talk about this for hours. This is a problem, and I find that people don't actually comprehend it, but it's actually completely parallel with what Basil Hiley was talking about quantum mechanics. So this is like quantum mechanics, the environment variable only, not all the fancy yeah, okay.
Thank you. I don't know if Valerie,
Is there a chance someone would like? I'm almost 80, and I've been doing this for 50 years. I was originally a structural civil engineer, and at the time we had to do things primitive ways, so computation was the thing. So I got stuck in computation and still stuck there. But no one wants to work with me. That's the problem. Anyway,
you know, I will tell you. I mean, I don't do quantum approaches to consciousness. That's not really an area of expertise of mine. I do brain stuff.
Yes.
But I will tell you, a lot of people write articles on that subject in the Journal of Consciousness Studies. So it is a field that is alive and well, even though I am not actively participating in it other than I publish their work. So.
Yes. But you're beginning to get a glimpse that you can actually deal with the complexity of it, the whole thing. If you can't deal with the complexity, then you're a bit stuck. And you have to try and understand what these mechanisms are. If you don't understand the mechanism, you can't. It's difficult to actually make sense of it.
Yeah. So I think my perspective is, you know, I only have a finite time in my life, and
mine is much smaller. Yes.
So early on, I had to place a bet. You know, I did my dissertation on consciousness. That's how long I've been thinking about this. And I'm way past the dissertation at this point. Yeah. So I had to place a bet early on about what I thought would be the most fruitful avenue for trying to understand and answer the questions I had. And I placed my bet on the brain. And so, you know, here I am almost 40 years later, and that's what I know. So, you know, I don't want to say you're wrong. I can just say, that's not where I placed my bet. And over time, I haven't felt tremendous need to change where I placed my bet. And now I'm probably too old to change where I placed my bet. But, you know, this is one of these cases where I think 1,000 flowers need to bloom. And eventually we'll either get it figured out or we won't.
Yes, I can see it. I can see it happening now, but
yeah.
Thank you, Niels.
Yes, okay, sorry, I won't.
Okay. Yes, we'll take the next question from Henry.
Yes, thank you very much. I've been looking for a presentation like this for a long time. I'm 85 and I've been wondering about these things for a long time. My simple question is, what do you say about the consciousness of the variation in consciousness we see in other kinds of beings? Dogs, cats, you name it.
Yeah. You know, and there's a whole gamut of opinion. And really, again, it comes down to placing bets. So, you know, if you believe in the neural correlates of consciousness, that's a way to approach things. Then you have to figure out, well, what is the neural correlate where I'm placing my bet? Is it 40 Hertz oscillations? If it is, then we can go and look for those 40 Hertz oscillations in other creatures. And we can say if they have them, then they're conscious. And if they don't have them, then they're not. Or if you think it's interactions between, say, the thalamus and the prefrontal lobes, you got to have the thalamus and the prefrontal lobes to be conscious. So if you don't have prefrontal lobes, then you're not going to be conscious. And so I think to answer those questions, I mean, the honest answer is we don't know. We don't have a clue. But if you're going to place a bet, what you would do is just do an analogy from whatever your pet theory is to whatever creature you're interested in. So some people, you know, they think, yeah, grubs, worms, of course they're conscious because they've got whatever property I think is aligned with consciousness. Other people think, no, it's got to be humans, maybe some primates, but you know, once you get beyond that, they're just not complicated enough. So that's about the best I can do there.
Thank you, Henry. We actually have a bit of a follow-up from Ferdinand. Rather than cats and dogs, what about other apes like chimpanzees? Is it same same answer, or?
Yeah, well, I would think that you're much more likely to find conscious experiences that resemble ours and things that are more closely related to us and are complex like us. So I would say yes. But at the same time, I don't know that I've got a definitive view about what consciousness is in the brain. But I do have, definitive is not the right word, but I do have views about the complexity of what our conscious experiences are like. And I think it would be highly unlikely that an earthworm would have the same type of experiences that I have. It's much more likely that a chimpanzee has the same or very similar experiences to what I have. And that's just because, I have the type of sensory systems that allow me to experience vision. Whereas, earthworms, they can't really do color the same way we do. So things like that. But again, it's all based on analogy, I think.
Great, thank you for that. Next question will come from Lena.
Yeah, hi. First, this was really, I'm fascinated with consciousness. Your presentation was really totally wow. And also I'm so excited about the journal, to know about the journal. For sure, I'm gonna go check it out. I've just started my degree in neurosciences that I just started because of the work that I was doing beforehand. And to hear you say that there are many types of consciousness to me is so wow, because this is what I've been always telling myself because of the work that I do. And to me, like being conscious about the fact that it's the daytime and being conscious, becoming conscious of the programs that we have recorded when we were small children. And that has been making us act in a certain way, which we were unconscious of. And then you become conscious of this. It's totally different type of consciousness. And the reason why I want to go into neurosciences is exactly to know what happens to the brain when you have that aha moment, when you have that into consciousness all of a sudden. It's something that's been underlying, like working in your life and motivating you and stuff. So to hear you say this, like, I'm really, really excited. I thank you so much for this presentation. It was really, really cool. So I was wondering about, what you thought about the difference between, those two types of consciousness also. And like, where do you stand, or how do you see this?
Yeah. Well, I'm perfectly comfortable with the idea that different parts of the brain or different interactions of the brain give rise to different types of consciousness, and we're going to have different explanations for each one. And certainly that aha experience that you're referring to in learning is very powerful. And there's a lot of good work being done, not so much in neuroscience, but in cognitive psychology on it, because of course, the goal is to help people learn and learn better and learn faster, so we can accelerate whatever it is we're trying to do. And what's most interesting, I think, about the aha experience is that it really does help when you're trying to solve a problem to stop working on the problem and walk away from it and have completely different conscious experiences, right? Don't even think about it. Take your shower, because that's where all good ideas come from. If you're taking a shower, and then it'll just pop into your head. Now, how the heck does that happen? Because clearly your brain is still working on it outside of consciousness, right?
Yes, yeah.
And so there's this weird interaction, I think, between whatever consciousness is doing for us and problem solving, and they're not always good partners with each other. Yeah.
Yeah, that's what I'm totally fascinated with. So your presentation was really like mind reacting type of thing.
Thank you.
Thank you so much. Thanks.
Thank you, Lena, and thank you for enthusiasm. Next question will come from Yonald.
Yes. Yeah, nice presentation, Valerie. Basically, I just want to take off from what Niels was saying. I think the problem with really considering quantum mechanics as a viable theory for the hard problem of consciousness is the present version of quantum mechanics accepted by 80% of physicists is really the Copenhagen interpretation, that this quantum collapse from chaos, and it all exists just in this physical material plane. But what Bohm is proposing is there are two layers of reality. There's an implicate order that gives rise to a physical layer. The strangeness comes from the giving rise to the physical layer. And the physical layer gives rise to our world. So basically what he's explaining is the implicate order, which is a layer beneath the physical, or you can say beyond, but beneath. It's all sort of proven through quantum potential mathematics. There's something existing beneath that cannot be accounted for physically in the physical plane. That might be where consciousness is sitting. It's not sitting in the physical plane, in the observed reality that we have. So the analogy that I have is, if you are a simulation in a computer, for example, if you're the Sims, right? So the Sims, they are like computer generated objects. They dig, they build houses, they plant flowers, but the flowers that they're planting are digital flowers. They have no idea that the ultimate nature of that digital flower is a coding in a computer hardware beyond their world. Okay, they cannot fathom that there's a computer running their simulation, right? So it's the same with what Bohm and Basil Hiley is proposing. There's our physical plane is just a manifestation of a hidden reality that we cannot fathom. And possibly consciousness stems from that. That's why we cannot solve consciousness. We're trying to solve consciousness on one layer. It's like the snake eating its tail. It cannot eat its whole body because it's existing in this one layer. So that's the difference between the Bohmian quantum mechanics and the Copenhagen traditional standard mechanics that just talks about chaos. So it's hard to pin consciousness on that kind of interpretation, which is believed by 80% of the physicists and most of the scientists in our world, including neuroscientists. So they laugh upon that idea. That's why I think the Bohmian model, which is accepted as an alternative, as a viable alternative model, they have the same chemical equations, should really be more taught in school. So I just want to comment on that. So I don't know if you have further reactions, Valerie.
Yeah. So the only thing I would caution in trying to use this approach to understanding consciousness, and this just comes from my perspective as a scientist and how I think science works, which is like cutting off little pieces of things and trying to figure out how it works, is you got to be careful of trying to explain the obscure by the more obscure. There's a very real danger of saying, wow, consciousness is really complicated. I have no idea how to understand it. I don't even know what it is. Quantum mechanics is really complicated. There are these different interpretations. It barely makes sense to me. These two have to fit together somehow because they're both weird. That's not for me yet a really good theoretical foundation for me to place my bet that a quantum mechanical approach is going to solve the mysteries of consciousness. Not saying it's wrong. I'm just saying I'm not seeing the linkage yet, other than it could be here, but then it could be in a lot of places.
Okay, let me give another, yeah.
I do know that, for example, if you remove parts of my brain, I lose my visual perception. And if I want to understand visual perception, it's probably a better bet that I start understanding how my brain works than understanding quantum mechanics. So for me, it's building up the little pieces till you get to the whole, as opposed to trying to start and understand, everything. And then from that everything, then I can figure out all the little pieces. So it's just, again, it's a difference of where you're placing a bet.
Yeah, can I say one more thing? Basically, it's not really doing away with science. Bohmian mechanics is really intricately linked with the physical world. Even the matrices and the differential equations really underlie the physics of that thing. But the thing is, the underlying reality is not obeying Newtonian physics. The way quantum mechanics is strange, right? So let me give you this example, the one I gave earlier. When you think of a thought in a previous discussion, life is meaningless. That's a conscious thought, right? It will trigger in the brain. It will make you depressed, right? But it will trigger in the brain a chemical reaction. It will lower your dopamine levels. It will lower your serotonin levels. So then you ask, how can thought influence that physical reaction? Because a chemical equation is basically for our entire universe is simply chemical A plus chemical B is equal to chemical C, or plus or minus energy on both sides. So how can that thought, that thought, it trigger the lowering of dopamine, the lowering of serotonin, there's no link between thought and chemistry, physical chemistry. So that's why I believe, and also Basil sort of ruminated on the problem, that the answer lies in quantum mechanics. Quantum mechanics is the first mover. And that's a vital part of the hard problem of consciousness.
Yeah.
First, how can physical systems influence consciousness? And second, how can consciousness influence physical systems in turn, right? And if physical chemistry cannot provide an answer, then probably quantum mechanics can. And if quantum mechanics can provide an answer through the quantum potential of the Bohmian quantum physics, then probably that's a vital part of understanding consciousness, the way consciousness affects the physical world. So that's where we're coming from. But of course, everything is fair play.
I get it. I just don't believe in the hard problem the way you do. I don't see it as a hard problem.
Okay.
I just think you don't see the correlations yet. And again, I want to caution you from saying, I don't see how thought could cause this, chemical reactions. How do these move between each other? I get how that's weird. But then the next thing you say, and so it's probably quantum mechanics. That's a big leap for me. That's a big leap.
Not with Bohmian physics, because if we understand Bohmian physics, quantum mechanics can make particles move. That's why there's a big difference between what people mostly believe. They believe in the traditional Copenhagen interpretation, which I think is wrong. But if you believe in the Bohmian mechanics, it can make particles move by itself. That means a thought can trigger particles moving through the quantum potential. What Bohm did is just convert the Schrödinger equation to an equation that has quantum potential, the Bohmian potential in it. Anyway, it's really, really high level stuff. But I'll stop at that.
Yeah. No, I'm in the Copenhagen camp. I just am.
Okay.
Yeah, that's not where I place my bets.
Yeah, so
I understand.
Let's move on a little bit, just because we're reaching the end of the session. I can see still one hand up. Guru Charan, do you want to ask your question?
Yeah, Valerie, thank you for a great presentation, by the way. I do read your things, and big fan of the journal, of course.
Oh, thank you.
So I guess in a short time, let me just say, I have two parts. I'm kind of on that bridge, of looking at both the quantum mechanics stuff in the tradition from Bohm, Einstein, Akira Harnoff in the Brain Institute, many different things. Also looking at the neuroscience. So I have two things. On the neuroscience, I wonder if you had any comment about Sugar's research showing that for example, the readiness potential ends up being a kind of artifact to a degree of the way the statistic is set up with chaotic systems, so that he can basically show that no subset of neural things that we know would be a decent account at this point, at least, for what we would usually call consciousness. Okay, so that was very interesting. Both he had the computational models of that, and he also was looking at the brain. So that's interesting, because we as scientists have looked at the RP for a very long time, like showing a preparation and perhaps thinking and so on. And in the end, now after 20 some years, that's maybe not the way to see it. And that's the way measures develop, like you say, a bit at a time. Secondary I deal with is really looking at the quantum mechanics. Most interestingly, I find a dynamic that happens between what you might call the parts and complexity and emergent forms of reference and consciousness, and a realm in which there's wholes that are irreducible and yet can show up in parts systems. And there's a way that happens very specifically. And by the way, Bohm, for you Bohmians, I had told Akira Harnoff that his approach to non-locality was literally the first level of implicit order and started bridging some of these other questions that the other gentleman mentioned. So I sort of have two things, but since you don't do quantum mechanics too much, what about Sugar?
Yeah, I don't, I have to say, I don't know that work well. And so I don't have a view. I mean, neither good nor bad, but my view always in all of this is we need to let 1,000 flowers bloom. And just because I didn't place my bets with quantum mechanics or a Bohmian interpretation of quantum mechanics or anything else does not mean that's not where the answer is going to come from. It just means that's not where I'm putting my energy, but other people should put their energy somewhere else, because if we're all trying to get in my sandbox, it's going to be a very crowded sandbox and we're not going to get very far. So I think, you know, all the work that's being done and replicated, I think is great. And hopefully someday we'll be able to put it together into a nice, neat explanatory package of correlations that we can weave together into a nice story.
I love your clarity and the ability to define a lane that you travel. And hopefully we could get in contact. We could chat a little bit about some of these other things that you might find interesting. Thank you for your time.
You bet. You bet.
Thank you so much for your question. Unfortunately, I guess we should close the Q&A as we've got just a few minutes left. Valerie, do you have any closing remarks that you'd like to give us before we close today?
So I'm going to put something in the email because I've been asked by a couple of people about the best way to get in touch with me. Hold on. I need to send this to everybody. Here we go. So this is my email, and you are welcome to email me. I try to respond quickly. If you don't hear from me relatively quickly, ping me again, because I'm not one of these who lets emails set for 2 weeks. But I also have a very crazy spam filter, so don't be shy about saying what the heck. No, I don't know that I have anything really additional. I don't have any glorious summary because I gave it at the beginning. I think it's really complicated. I still think it's really complicated. I suspect the answer is going to be very complicated and probably involve a lot of different pieces that we don't know how to put together yet. So I do want to thank you for your time and your interest and your engagement with these topics. It's been very gratifying. I appreciate it.
Thank you very much.
Thank you so much, Valerie. And yeah, thank you for sharing your email address. For those who maybe won't catch it or something like that, feel free to just email us. And if that's okay, Valerie, we can share it on your behalf. So yes, thank you for your presentation, Valerie. Thank you for all of those who participated. I hope to see you all next week, where we'll have our final weekend for What is Consciousness. So on Saturday, we will have Richard Baker-Roshi, who will have his presentation entitled The Inner Science, Experimental Investigation and Analysis of Consciousness. And then on Sunday, instead of McCogra's session, as he had to postpone his session, we will have our closing panel discussion. We'll have Valerie again, we'll have Gary Lackman, Roderick Main, Pavel Pilkanen, and Beverly Zabriskie. They'll be discussing the various topics that emerged in this few weeks and answering questions from you, the participants. So make sure you've got your questions ready. Thank you again, everyone. To contact us, you can email us at james@powercenter.com to contact me, or eleanor@powercenter.com to contact Eleanor. Otherwise on Sutra, Facebook, Twitter, website, all sorts of communications. Thank you again, and we'll see you again soon here at the Power Center.
Thank you, James.
Thank you, Valerie. Thank you, James.
Thank you, Valerie.